Okay, this question again is just a little bit different. It's a little bit out of the ordinary. You've got to be taking a little bit of care with it because again, just applying a formula is never going to work with this one because the number of compound interest amounts at times it's being compounded is different to the amount of payments that are being made. So if we look at the question, you got Jill has 180 put into 100 into a trust account and gets 12% per annum interest and it's compounded annually. It's deposited at 180, so it's an annuity, gets put into the account every time Jill had a birthday, and the last payment was paid on Jill's birthday, 16th birthday. So what we're looking at is that $180 is put in when she's born, and then the last payment is on her 16th birthday, which means that she makes 17 payments all up. So there's the first thing to remember and be aware that there's actually 17 payments that need to be put in. Okay, so what happens though is what we want to do is calculate the total amount in the account on Jill's 25th birthday. So we pay the 17, there's 17 payments put in, but then it starts to earn interest every year up until her 25th birthday and find out what's going to be the amount in her 25th birthday there. So what we're looking at, start off our pattern. We've got 180 invested when she's born at 12% per annum interest, and it gains and it's invested there for a year. So that's how much it's worth after 1 year. So after 2 years, we've had 180 put in on her birthday at the start of the second year, and then it has interest earned on it for the year. So that's why it's multiplied by the 1.12. So there's what our expression looks like. Then we expand it out. So that keeps going through. So until the 16th, and after 16 years, and then after 16 years though, that's after her 16th birthday. It's going to look like that. So after 17 years, then, so sorry, after 16, the 16th birthday gets put in. So after being invested for 17 years, then we start to get the expression A17 here, which is 180, 1.12 to the power of 17, 1.80 to the 1.12 to the power of 16, right down until 180 times 1.12. So after that amount of time, that's how much it's earned. So then in the 18th year, after 18 years though, what happens is just this amount here is multiplied by the 1.12, and that goes through until the 25th birthday. So there's your, so after the A17, and then it's just going to keep earning the 1.12, and that happens till she's 20 until 25th birthday. So that's what it looks like then. So after 25 years, their statement looks like that. So there's the last repayment. There's the first one that was put in. For 25 years. Okay, so then we're going to have to calculate this. Now notice that it doesn't go down to 1. It goes to 1.12 to the power of 9. So if 180 gets factorised out, our first term is the 1.12 to the power of 9. That's where it's different. That's where someone just doing this with a formula is going to have trouble. They're probably not going to get their A right. They're going to probably get the R right because it's 1.12. But again, will they get the number of terms right? Because a lot of times people just look at the 25 and go, oh, I'm going to throw that in. But there's actually 17 payments being put in. Okay, the one that was initially put in, and then the last payment made on her 16th birthday. So that's how many repayments have been put in. So we got the 180, the 1.12 to the power of 9. There's our R to the power of n minus 1 over the 1.12 minus 1, and then it calculates up to 24,449 cents. So be really careful. This one's again a little bit out of the box. It's just a little bit different, so that you can't really apply a formula. You have to set up your pattern and understand exactly what's happening. Understand how many payments are put in, what the first term will be in this case, because it's a little bit different. In question 6 here, we've got a situation where Jack's born. His parents put $100 into the account. at 6% compounded interest, compounded annually. So, and they keep doing this, and up to and including his 17th birthday. So when Jack leaves school on his 18th birthday, they then deposit another $1,000 into his account. Again, just a little bit different. So you got the annuities, and then right at the end, they're going to put in 1,000. So it's going to pick out people who are trying to put a formula in. Show that firstly the initial $100 had grown to 285.43 by Jack's 18th birthday. Well, there we go. After on his 18th birthday, it's been invested for 18 years, and that's the initial amount, which is the compound interest. So we apply it there. Now what we're going to do is calculate the total amount in Jack's account when he left school. So there's our first amount. After 1 year, the first $100 is multiplied by the 1.06, and that's what it's worth. At the start of the second year, you've got what he had left of the first year, plus another 100, apply the interest, and then we can expand it out. So after 18 years though, that's what our pattern looks like. So the 100 times the 1.06 to the power of 8, that's that initial amount, so that's that one there. And then there's the one from the second year, so that's that amount is calculated now to be compounded 17 times. And then it goes on until the last $100. That's the $100 he was invested at his 17th birthday. That's only had 1 year of interest applied to it. Don't forget that on his 18th birthday, they put in an extra $1,000. That was very nice of them, but they've put that in. Again, that starts to make sure that you are understanding and reading the question. So this part here comes down to a geometric progression. Factorise the 100 out. Our first term would be 1.06. Our ratio is 1.06. And we've got 18 terms because there was 18 payments for the one where he was born, and then everything up until his 17th birthday. So we substitute that in. There's the R minus the 1. Comes out to 3,276 plus the 1,000 that they put in on his 18th birthday, gives him $4,276 at that for that amount. So just again, be careful. You've got to read the question, understand exactly what's going on in the question, and is there any little subtleties that exist. There's a bit of reading, but you've got to identify the important parts.